All right, everybody. Today we're going to be finishing activity 2 with lesson 2-2, and we're learning about deductive reasoning today. So what you're going to need is make sure you have your springboard book, a pen or a pencil, highlighter, and even your vocab sheet handy so you can fill in some new vocab words that we're going to learn today. Okay, so before we actually get into the lesson, I have a little story for us. So suppose Jane Doe buys coffee at a local store every day at 7 a.m. One day that store is robbed at 7 a.m. So is this proof that Jane Doe robbed the store? So take a minute and think about that. Hopefully most of you are saying, no, that's not necessarily true. Just means she could have been there when the store got robbed. Or maybe you're thinking, yeah, that's true. She's there every day at 7 a.m. She probably did it. Okay? So what we just went through in our minds here is using the thoughts of deductive reasoning to prove that a conjecture is true. Okay, so yesterday we learned about conjectures being an idea or thought based on an observation that we see through inductive reasoning, right? So with deductive reasoning, okay, we have to use these things, certain methods and rules called arguments. Now, an argument is not a disagreement in this context, okay? Instead, an argument is a series of reasons or facts that support a given statement. So, our conjecture, in order to prove that it's true, we need to use arguments, okay? And the way we do that is this process of deductive reasoning, okay? These rules are called rules of logical reasoning, also known as deductive reasoning, okay? An argument that follows such rules is a proof. Now, I'm sure you've heard of proofs before, and we're going to learn a lot about them in geometry. But a statement or conjecture that has been proven, established as true without a doubt, is called a theorem, okay? And the way we prove a theorem or turn a conjecture, an idea based on observation, into absolute without a doubt of true statement is by using a proof. A proof transforms a conjecture into a theorem. Okay? So this middle section here would be our proof. So the proof is a bunch of arguments we use to back up our conjecture using facts. Okay? So here's some definitions of arithmetic, so you can use those to kind of prove things. So for example, deductive reasoning, something like proving an even integer, we know it's divisible by 2. We can prove that, okay, by showing actual facts and arguments to actually prove that that's a true statement. All right. So let's skip to page 22. We're going to skip a good chunk of this lesson today and kind of just worry about the main points. So let's compare and contrast a theorem versus a conjecture. So I want you to take a minute and think about what's the difference between a conjecture and a theorem. Well, hopefully you were remembering that a conjecture is just an idea that we base from an observation or a pattern we see. Okay, and remember, it may or may not be true, which we saw in our lesson yesterday. Okay, remember the pattern we were observing when we had the circle and the points along the circle. We were saying that the number of points gave us, if we connected the chords, okay, gave us the double amount of non-overlapping sections. So our conjecture was that every time we increased a point, we doubled the amount of non-overlapping sections. But if you remember, we proved or we saw that that may not always be true. We saw a time when we thought it'd be 32 sections, and we only ended up with 31. Okay, so a conjecture may or may not be true. It's just something we see and make an observation about. Versus a theorem, the theorem goes through the process of proving through arguments that it's actually true without a doubt. Okay, so let's look at question 13. Question 13 says, Todd knows that 3, 5, 7, 11, and 13 are prime numbers. Now, what's a prime number? If you remember, a prime number just means its factors are 1 in itself. There's no other factors to the number. So based on this evidence, he concludes that all prime numbers are odd. So this is his conjecture. Do you think he's using inductive or deductive reasoning here? Hopefully you said that Todd is having inductive reasoning, okay? Meaning it's not proven to be a fact yet. He's just saying he notices all these numbers are prime and also odd. So he's making an assumption that all prime numbers are odd. So is his conclusion correct? Can you find anything to support or not support his answer? So when I think of this, I think of the example of the number 2. 2 is a prime number because its factors are 1 and 2, but it's not odd. Okay, that's an even number. So technically his conclusion is not correct. Okay, so I want you guys to try 14 on your own. Shayla knows that all rectangles have 4 right angles. She knows the figure ABCD is a rectangle. She concludes that figure ABCD has 4 right angles. So is Shayla using inductive or deductive reasoning here? And make sure you can back up your answer. Okay. Hopefully you said that Shayla's having deductive reasoning in this case. Okay. Her conclusion she made is based on a fact. She knows that rectangles have 4 right angles. She knows that this figure is a rectangle. So by deductive reasoning, she has proven that ABCD is a figure with 4 right angles without a doubt of anything. She knows it's for sure facts. So is her conclusion correct? So is Shayla's conclusion correct? Hopefully you said yes, okay? Her conclusion follows logical statements, okay, about rectangles having 4 right angles, and therefore she can prove, again, without a doubt, that that figure is a rectangle. Okay, so that's deductive reasoning. So again, inductive, you're just observing a pattern and you're making an assumption about it. Deductive reasoning, you have facts to support your claim, okay? So you're not just saying something happened. You're not just saying Jane Doe robbed the store because she goes to get coffee at the same time every day, okay? If police did that, it wouldn't work. You need to have facts to back up your statements, okay? All right, guys, I'll see you in the next video.